Hello and welcome to my tutorial on phenols. So, what are phenols? Phenols are organic compounds that are benzene rings attached to an OH functional group. So one of the hydrogen atoms have been replaced by an OH group. And they are also slightly soluble in water because of oxygen's lone pairs. On the oxygen atom there are 2 lone pairs and 2 bonded pairs of the hydrogen atoms, and this slight attraction is what allows it to be soluble in water. If that attraction cannot occur, then it cannot be soluble in water. But phenols are slightly soluble, but because of the delocalized structure of benzene, it is only slightly soluble because of all those delocalized electrons there. So first off, we look at an example here. We start to identify that it's a phenol, and on the second carbon we have an ethyl group here. So to name them, you look at your benzene ring to start off with and go, oh, it must be a phenol, there's an OH group there. So first you write phenol, and then you go clockwise 1, 2, 3, 4, 5, 6 logically, or you can do it the other way around, as long as you do it logically. So first you find your ethyl group on 2, so that'll be 2 ethyl phenol, or if you really wanted to do it the other way around, it would be 2 ethyl phenol either way, because if you counted logically, it would be exactly the same. If I go clockwise or anti-clockwise, it makes no difference. And you can also have the OH inside a group. So 2-phenylethanol is quite basically a phenol with benzene with ethanol attached to it. As long as this OH group is present and a benzene ring is present, you can call it a phenol. So those are the 3 common examples that usually come up. Now I'm going to talk about the different reactions with sodium hydroxide and sodium on its own. So first we're going to talk about the reaction with sodium hydroxide. So if I have C6H5OH, our basic phenol, and we put it in water, aqueous, I've called it, we get the C6H5O- ion and H+ ions floating around in the water. So then, if we add our aqueous sodium hydroxide, I'll just put an aqueous there, with aqueous sodium hydroxide, put another aqueous there, we get C6H5O- Na plus H2O, and then it tidies itself up like this. It goes benzene O- Na plus H2O to cancel out those charges with the extra H+ ion there. H+ ion was a catalyst, and it is not regenerated, so I can't call it a catalyst. Actually, it is a species that does not regenerate itself. So benzene is directly attached to O- and Na+, and that's all you need to know. This is called sodium phenoxide. Sodium sodium at the start because it's got a sodium+ ion, and phenoxide because it's got the oxygen attached to the benzene ring. And it's also got the pheno prefix because it used to have an OH group there, but instead of a H, it has an Na+ now, and it's an ionic attraction between the oxygen and the sodium. Now we move on to the reaction with sodium itself. So if we have 2 lots of benzenes and 2 sodiums, we get 2C6H5O minus Na plus H2 gas. No H plus ions this time. So the graphical way of writing this is having 2 phenol groups plus 2 sodium atoms to make 2 of the same product last time, sodium phenoxide, plus H2 gas. So this reaction tidies itself up a bit more, and rather than having the byproduct of water, we have the gas instead. Gas is nice. And that's it about phenols, really. Okay, so now we'll go through bromination and the uses of phenols. So the bromination of phenols is quite simple. If you get a phenol and 3 diatomic molecules of bromine, this will happen. 3 bromine atoms will bond to the phenol, and 3 moles of hydrogen bromide will be produced. This is known as 2,4,6 tribromo-phenol. So it's 2,4,6 tribromo-phenol, in case you wanted to know. So now I'll go through the uses of phenols. And phenols are used in quite a few things actually. Methylphenol, as we looked at earlier, is used in detergents. Well, no way. And chlorophenols, like this, 2,4-chlorophenol, is found in antiseptics and disinfectants, such as Dettol. And salicylic acid is used in pharmaceuticals. This is where the future medics should be absolutely interested, because this is how you make your pills. And bisphenol. So this is 2 benzene rings with 1 carbon attached to 2 methyl groups. Yeah, it's getting gnarly now. Which makes paint, epoxy resins for paint. So this is the stuff that makes the paint a bit thicker. So that's it really on phenols. One final thing to appreciate is the delocalization of the benzene ring being changed again. So the non-bonding electrons of the oxygen atom in the phenol group are drawn into the benzene ring, and the lone pair in the oxygen overlap with the delocalized electrons in benzene in order for this all to happen. So this could also happen with oxygen, not just with bromine. So it's nice to appreciate that, and I hope you found this tutorial useful. So in the textbook we covered 1.1.7 to 1.1.8, and next tutorial we'll go through carbonyl compounds. So I hope you found this useful. Like, comment, subscribe and all that YouTube jazz. Thank you for watching, and goodbye.